Good afternoon. For those who are here, I'm just opening up the webinar. I see people are still signing in. We're going to go ahead and wait till 12:45 to get started. But if anybody has any questions, there's a type question box, or there should be on your viewer, and you can enter them there. I've got Abigail assisting me on the other end of this webinar so that hopefully we can address any situations. But we'll be starting here momentarily. Thank you. Good afternoon and welcome to ECB's Tuesday, Thursday series of webinars and trainings and professional development hour or continuing education unit credit opportunities. My name is Alex Zimmerman. I'm the technical manager at ECB Verdial. And today the topic is biotic soil amendments and case studies in project delivery. When I team up with projects, I've got a few goals that I say are necessary on every job site. We need production, we need profitability, and we need compliance. And I have found that the new category of biotic soil amendments offers opportunities to address all three of those things very nicely on projects. So I will go ahead and get started here. There's a pretty nice shot there of some long distance biotic soil amendment application. And the question we're really asking ourselves is, does the importation of topsoil, is it really necessary on projects? There's been a lot of discussion of where do we even get the standards for what is good topsoil. I think oftentimes we've just got a darker colored dirt that we're paying a significant premium for. Our goal on every project is not just to successfully germinate grass species or vegetation, but it's to create sustainable vegetation. And that's something where the nutrient cycling is happening. Mother Nature's taking care of herself. We don't do maintenance of prairies and grasslands and apply fertilizers. There's microbes, there's bacteria, there's fungus, there's a whole entire soil food web that creates the necessary environment to keep our sustainable vegetation going. And our careers in erosion and sediment control have focused quite a bit on the temporary mulches or temporary erosion control blankets, but oftentimes when it came to the soil, we sort of hoped for the best. Sometimes we would try to specify what would be necessary for organic matter and what truly soil is, but often it was just some type of starter fertilizer and spray and pray. Well, when we look at what soil is made up of, it's actually alive. And I believe that there is a difference between dirt and soil. And soil has the microbes, the bacteria, it has nematodes, fungi, protozoa, organic matter, water, airspace. The mineral component of soil is not that difficult to arrive at, but the living organisms, that's the difficult part. And when we increase that organic matter, we also improve water holding capacity, which all plants need as well. So if we look at our current practices and what we're doing on our projects by bringing in, importing, or when we're lucky and we can salvage and stockpile our strippings and our initial topsoils, it's an awful lot of cost, it's an awful lot of effort for a very small portion of the actual soil that is necessary. You know, the mineral portion is about 45%. About half of our soil profile is void space. That's where moisture and air is going to operate. And then we got a very small amount, 5%, that's organic matter. So what biotic soil amendments offer in terms of convenience, cost, and time savings is a replacement or an alternative to both topsoil placement and compost placement. And we find that many projects go through significant effort trying to spread topsoil, manage topsoil, harvest topsoil, import topsoil. And then there's projects where it's simply not viable. The project is remote, there's no topsoil nearby, delivery costs would far exceed feasibility, and biotic soil amendments offers a convenient, economical method to address all of those situations. On typical construction sites, you know, a lot of our topsoils are lost. Oftentimes we consider that to be waste and we get rid of it. We compact soils pretty significantly when we have the heavy equipment operating and doing standard construction, which loses our porosity. We lost that living soil food web that's present in healthy soils. When we do harvest soils and stack them up, we can even be degrading them further. In a pile, the anaerobic environment that is created in that soil stockpile is going to be further degrading those natural microbial communities that are so important for healthy plants and successful revegetation. So we're looking for alternatives to some of the traditional standard methods and alternatives that improve our outcomes, production, profitability, and compliance with regards to establishing final vegetation and being able to terminate any open permits, close out a project, or be final payments with our contractors. So all of the standard practices and methods of typical topsoil management have the piling problem. When you talk to topsoil harvesting professionals, they'll advise against the traditional stockpile of topsoil, and they'll recommend typically not more than about 1 meter deep, and then it's important to turn that topsoil stockpile regularly to prevent that anaerobic environment from further degrading. Best practices would be to even grow a cover crop on a very very thick pile to keep that soil food web alive, and that's just not feasible. So with biotic soil amendments, what we're bringing is a prepackaged, easy to load in a hydro seeder with the seed and any tackifiers that may be necessary for your erosion control needs, and use that existing equipment. These guys are a Washington State Department of Transportation maintenance crew, and this is their first time with a hydro seeder. It is remarkably simple once they know just how to run the mechanics of the hydro seeding equipment. So oftentimes contractors find that they're being able to get a secondary use out of equipment. They're able to replace an awful lot of earth moving activities with regards to hauling, trucking, spreading, stripping topsoils, and hydraulically apply a product that we know has all of the beneficial microbial communities, organic matter, and creates a really nice environment for growing. Here's an application where a hydro seeder is just put on a shipping skid. This is fairly remote. This is at the beginning of the Aleutian island chain in Alaska on a project there. So there's lots of ways that we can mobilize into hard to reach areas. Yes, that is two fellas standing on top of a hydro seeder flying through the air with a crane. Here we have another hydro seeding unit on the front of a loader and being able to access areas that way. These This crew figured out how to, with biotic soil amendments, just kind of make their own pipeline in a cannon to get into remote areas where stretching out hose would be kind of problematic, or possibly require aerial installation, which can get a little pricey when we're getting into helicopter time. So just wanted to walk you through some of the projects and how the choices to use biotic soil amendments were made, and then the results. So the picture of the hydroseeding equipment that I showed you on the shipping skid there on a semi-trailer is this project here in Dillingham, Alaska. Now the project is a runway extension, which is fairly common. Making the runway safety areas larger, allowing for a little bit more accommodation of larger planes. And so down at the far end of that runway, we're going to go out and we're just going to make the whole thing longer. Now, when we do that, you kind of look at the logistics of this. There's not going to be much topsoil to be saved. And when we bring in all that embankment fill, there's not going to be much of it left. And so by the time we round up the end, towards the end of the project, this is the type of soil that many projects are faced with trying to revegetate. Pretty much just a mineral till, not a lot of organic matter, not having those microbial communities that are going to be necessary for the nutrient cycling. So biotic soil amendments allow us to hydraulically apply, in this case biotic earth, with the seed and fertilizer. We're finding that the fertilizer applications are actually a bit lower. I'm used to now going with a 4-6-4 slow release organic fertilizer. I'm not doing 16s, 19s, 20s anymore for the fertilizer. Because part of what's going on here is the bacteria that are present in the biotic soil amendments are going to start fixing nitrogen, both atmospherically available nitrogen as well as nitrogen that's tied up in decomposing leaf and plant litter. I always love this picture because I like to joke around that, see, you can just drive down the edge and spray it on and it's growing grass almost immediately. This is actually a couple different applications, but 24 hours of sunlight does help. And I'd also like you guys to take note of the timing. We are seeding these slopes for revegetation prior to placement of the base rock on the runway area. So one thing that we've learned on our projects is that getting going on some of this revegetation effort and taking advantage of some of the time we have is paying huge dividends. Now, I don't want folks to confuse biotic soil amendments with the erosion control aspect of this. The biotic soil amendments are not the erosion control. Now, with some tackifiers and additives, they can function to reduce and limit erosion, but they're really not the main driver of this product category. So the appropriate erosion control to place on top of the biotic soil amendment installation is always a critical component to the design. Now, I love the testimonials from contractors, and the superintendent on this project, they used the Vertial Biotic earth for the first time. It was a little bit different for them than the mulch, but found that they were able to get right through that, got good support from their product representative at their supplier. In this case, it was Alaska Garden and Pet, and saved them a ton of money. And when we start seeing those results, the simplicity, the use of equipment that's already there for a secondary purpose, the speeding up of the project timeline, and the closing out of a fully revegetated site with zero callbacks for maintenance and operations, those are the goals we're looking for. So here's the grass coming in, and the runway still is not paved. So this project still hasn't closed out, and yet we're already seeing the beginnings of successful restoration. This is in the same project year. Now you see the base rock is in at the top of the slope there. So paving will be following shortly. But by the time this project gets paved out and the stripes get painted on the runway surfaces, they're going to be looking over the edge, and they're going to be at full restoration. They're going to be done. They're looking at project closeout, permit termination, and not having maintenance callbacks. I wanted to take you to a different location, and I don't know, as I've gotten older, I've tended to find myself a little bit closer to fewer people and less asphalt, and I do enjoy working up north. So this is Cordova, Alaska, and the challenge with this project was you really needed to get the vegetation in because they were doing battle against an invasive species. In this case, it was Japanese knotweed. And it's a very aggressive species, so it's very difficult to completely eradicate. A very small piece of this can take off and start the entire problem all over again. So usually there's a removal phase, then you really want to get vegetation growing in strong and thick to choke it out. Typically got to come back to do some type of chemical treatment to the knotweed plants themselves. I've been involved in projects where we have to go around with literally a syringe and inject the herbicide into the knotweed to get full eradication. But here we are. Let's miss the date. I think we're just maybe 2 months after the installation here, and we're getting good growth. We got a little bit of knotweed coming back. That's that broadleaf plant you see there. And we'll go in and individually spot treat that. But again, those testimonials that come back from our project teams in the field, they really drive our company to keep on succeeding. So we found that on this project, the agronomist from the Plant Materials Center got involved because this is a required managed weed that had to be taken care of. Otherwise, it can take over and choke out all kinds of beneficial native species. And the testimonials speak for themselves. And here they had an installation that held up to what was considered a fairly significant rain event, 5 inches in a 48-hour period. And everything stayed in place. The germination improves. We found that the biotic earth with its darker color, does a nice job of holding a little bit more of the temperature. So when we get into the shoulder seasons or into more difficult climates or short growing seasons, we see marketable improvements in the restoration success as well. Here's another typical highway job, and we got cut slopes. If we had salvaged what topsoils we had, you can see that would have been a fairly difficult program on this type of a project, which is not uncommon. This back cut slope, we've got our fiber rolls or stem logs or wattles breaking up our slope lengths. Put the biotic soil amendment, always got to provide for drainage. You see we've got some rock drainage areas there. But stabilizing soils, managing concentrated flow, those are kind of the two cardinal rules of erosion control professionals worldwide. And we're sticking to them very well here, and we're seeing the successful results. Right? Even in shadier areas where it's a little bit cooler, we're getting great grow in. Again, another typical till soil, lots of silt, a little bit of cobble and rock there, but not much with regards to the organic matter, the living aspect of soil. So again, a hydraulic application, biotic soil amendments with seeds, some starter fertilizer in the same growing season. And a lot of people talk about there only being 2 seasons in Alaska, that being winter and construction. And we are seeing successful revegetation in that one season. So 30 days later, we got vegetation established. And on this project, over the alternative or standard project specification, which did require the placement and spreading of topsoil, this allowed for a 30% savings on that budget item. So when we can get a better result with less cost and less labor, I think we've got something that we're going to want to use on many projects. This is an interesting arid climate case study. This is Department of Transportation, Washington State, actually where you saw the fellows loading the hydroseeder. And they had done a traditional seeding with some straw mulch. And, if you're in an area where we can actually harvest the wind, straw mulch might be a little bit problematic. A good chance that's going to blow away. And so what they wanted to do was get that vegetation established and figure out how to, in a arid environment, you can see we're pretty much a desert here, apply seeds, mulch, get some extra moisture retention. And the nice thing about the Vertial Biotic Earth is we can hold over 1,000 times our weight in water. We have a peat-based, a sphagnum peat-based, very clean, weed and seed-free product. We do that testing on a regular basis, and apply that with our hydraulic seeding equipment in a fairly easy mix. So there's the slide duplication. Boy, it happens to all of us. Another advantage to some of the biotic soil amendments is tank loading capacity. We get a staggering amount of biotic earth in the tanks with our recommended mixing rates, and it can be a little scary for the first load of the contractor. We're, kind of, it's like, we put how many bags in there? And a little bit of concern about plugging and clogging. It blends up so nice and so completely that we find that increased loading allows our tank loads, when mixed to specification, to cover more area than a typical biotic soil amendment, and certainly most of the mulch products that are out there that we'd be placing on top. So it takes fewer loads, less time. That's less money. So here we got our biotic earth going down. When it goes down, you start to notice almost I describe it as almost looking like a pudding. It kind of has a shiny nature to it. 3,500 pounds per acre is our recommended installation rate. And it's fairly easy to calibrate ourselves with that look of the pudding shiny sheen and knowing when we've achieved that. I mentioned earlier that Biotic Earth was a peat-based biotic soil amendment. Part of the reason for that is just what a wonderful carbon to nitrogen ratio using peat sets us up for. 30 to 1 or lower, as the UC Davis College of Agriculture, Environment, and Sciences pointed out here, is about ideal. And so when we look down here at where we sit with different carbon nitrogen ratios, wood fiber is pretty darn high. And so when we use that as a medium, we start to run into competition challenges where the microbes and the bacteria that are breaking down and fixing nitrogen to make it available are also then consumed breaking down the wood fibers. So when we use a sphagnum peat to start off with, we wind up with about a 50 to 1 in the natural peat. Now, when we blend that peat with our microbial mix and our straw and flexible flax fibers, our ratio comes out to around 29 to 1. And that is about as close to perfect being 30 as we think we can get. So we have been working on this recipe and testing this recipe now for well over a decade, and have figured out a way to bring to the construction industry and the revegetation industry a product that is hitting all the right ideal characteristics for creating an environment that will better grow vegetation. And here we see some really nice expression in that arid area, and that's going to get us up well before the onset of winter and hold everything together so that these crews no longer have to worry about coming back and repairing this area. Now, it is an arid area, so all plants need moisture, but this is really good vegetation for the eastern desert side of Washington State, and also growing through drought. Again, that increased moisture holding capacity, the other advantage of peat that Biotic Earth brings to the table, is only improving our performance. Gotta have good erosion control. And this is a very windy area, as we noticed from the wind farm. So they actually lost some of the application there on that corner as the wind would come whipping out of the Columbia River Gorge. That's this location here. So we always recommend more information is better. And if we can run a soil test, they're typically not that expensive in your area. We'll get a better understanding of what the growing environment currently exists at. And so here we've got, very low organic matter. pH looks pretty good. It's right in there neutral. Don't want to be above 8, certainly not above 8.5, without starting to consider some type of pH adjustment. I typically find, sometimes we have low pH, that occurs as well. The closer we are to neutral, the better the plants will be. And so, again, here's another wind farm, so we know straw mulch will probably be pretty problematic. But they really want to get these pads revegetated. They don't want erosion around the foundation of these things. So getting a good, healthy stand of vegetation is pretty important to them. Again, we see we don't have great soils to work with. Not a lot of organic matter here, don't have that living element. So by applying biotic soil amendment to these existing surfaces. Can you imagine trying to haul topsoil around every one of these foundation pads and spread it around, mobilize the bulldozer to the other one, whereas we can mix up a tank load and get several of these things done in one trip. So here we've got some nice initial germination, again, fairly arid, fairly windy area. Another project from Texas. So we've gone from Alaska all the way down to Texas, and here we have a project where it was a test for the Department of Transportation. And so this line that you see in the foreground, that's the line between where the biotic earth was applied versus the standard seeding. Very high temperatures by my standards, 100 degrees, and no extra irrigation, and yet we still got successful revegetation. Project started out with less than 1% organic matter. That's very low. Remember, we're looking for about 5. So when we see these low organic matters on our soil tests, pH is climbing a little bit higher here at 7.8. We get an idea of what type of other amendments we may want to be considering. Here's another project. This is also from Texas, but again, you see that clear, definitive line of the vegetation coming in versus where the standard seeding in the foreground was not very successful in achieving those project goals. Another problem when we don't get our desired species in is competition from weeds and invasives. We want a nice, healthy stand of sustainable vegetation to help choke out those problems that are going to be costly for maintenance and operation crews down the road. This one, given the dry conditions at the time, there were some significant doubts that they would get vegetation. By the time they came back to do their assessments and they're looking at this project, they're like, holy smokes, this is better vegetation than we see under optimum conditions. And so we've really improved the environment that the plants are growing in. We've given Mother Nature the right parts and pieces that she needs to do what she does best. And then we just get out of her way. So you set the stage, you serve it all up. We've got the right microbial communities. We've got the right water holding capacities. We've got the right organic matter, and we've got it applied properly with our seeds and just set the stage for success. So here's an example specification. And to any of you who are in attendance, if you would like example specifications, we've got plenty of opportunities to get that to you. You'll receive an email at the end with your continuing education units. You can reply through that, and that will reach us, and we will get that information to you. So here's another, just a side-by-side comparison test. A lot of places like to run these. You know, they want to feel some confidence before they fully commit to an alternative way of doing things, which is completely understandable. Here we've got a slightly higher organic matter, 4.7. So we've got something to work with. However, you know, the project owners are still looking at these projects and they're saying, you know what? The success on the other projects is worth the cost. The cost is much less expensive than ever having to come back again. And we're going to go ahead and do it anyway. Sometimes the organic matter isn't the desired or the best kind of organic matter. Most organic matters, you want them to be nice and stable. And that's the other thing about the sphagnum peat moss. It's a very stable, long-lasting organic matter. And here we see some nice grow in occurring. Here's the same, guess we're on to a different project. Oh, back to Alaska, but way north. This is Kotzebue. Now this is a, it's a park, more frisbee golf than ballpark, but you know, general park fields. But this is September, so we're already getting pretty cold. Again, being able to retain some of that heat when we have the darker color can be very helpful. And so, you know, by mid-October, we've got, you know, the plants are coming up. It's gonna get a little too cold for them here and everything's just gonna kind of sit until spring. But by being able to push that vegetation on the germination side of things, we're gonna get our roots deep enough to avoid significant winter kill, even when we spend the entire winter under snow. Here's a installation. This is from the Maritimes up in Canada. Got a great partner contractor up there with Maritime Hydroseeding, and they install the biotic earth with the seeds and the fertilizer, and their preferred methods of erosion control would be to blow straw mulch on the top, adding a bit of an insulating, reduce evapotranspiration a bit, and depending on the region that you're in, the access to resources, whatever proper erosion control is good for your area, we think that's just great. And so they were able to do just a straw mulch here. And here we are 4 weeks in. Here we are 6 weeks in, and we're just seeing a nice, healthy stand within 2 months. We call this success. We're project closeout. Here we are in Kenai, which is on the Kenai Peninsula, south of Anchorage, back in Alaska. And there's a lot of riverbank erosion. That's a deck of a fishing lodge up there at the top of the slope. They don't want to lose that. But I just want to show you that there are some other really clever installations. This is using a turf reinforcement mat that we can infill with the biotic soil amendment because we still have the same soil problems. This eroded riverbank isn't going to offer much for topsoil without some significant effort to import it there. And so put the biotic earth into the turf reinforcement mat, then covered it up with a bonded fiber matrix for the mulch aspect. And here we have now a green vegetated armored solution in conjunction with turf reinforcement matting that's going to protect that bank. And this is the same deck here on this long fishing lodge. They have quite a business of that there. And you notice how the banks around them are still eroding, where we've got this really healthy stand of vegetation below that deck now that's going to prevent that bank from eroding any further and putting their structure in any kind of risk. Just successes from all over the place. Every kind of environment you can imagine, we've seen the benefits from using biotic earth. So here's just another test up in the boreal forests of northern Manitoba, and you just see the increase in density, the better color of the vegetation. When we go back and take core samples and pull out plugs, the root density and depth is markedly different in areas that have been treated with biotic soil amendments compared to those that have not. So the foreground is the biotic soil test area, and then where it starts to get a little bit yellow in the background, that is where just standard seeding was applied. Now, one can argue standard seeding is working. However, when we start to look at the type of root development that we get in the biotic soil amendment, which is the plug sample on the left, versus the standard seeding without the incorporation of biotic soil amendments, which is the test plug to the right, you can see a marked difference in our root density and depth. And what we really want to see is those deep drive-in roots. Those are going to be accessing more minerals, more nutrients, more water sources, going to improve their drought tolerance because they're going to be able to get at more access more available nutrients in their environment. So one of the other things that we haven't talked about yet much that is incorporated into biotic earth as a biotic soil amendment is the mycorrhizal fungi. Now, we put this in there because all plants, almost all plants, shouldn't say all, but it's well over 90% of plants form a symbiotic relationship with fungi in soil. And what happens is the plants will secrete sugars through their roots that the mycorrhizal fungi needs. So that's a benefit to the fungi. But with those chemical secretions through the sugars, the mycorrhiza knows what the plant needs. And the mycorrhizal fungi acts like a very thin tube and expands the reach of the plant. So in return service in their symbiotic relationship, the fungus extends the reach of the plant by being able to bring back to its roots from a distance of about 5 times the roots mass, out about 5 times can bring back those nutrients to the plant. So you see the increase in density, you see the improvement in depth, and that just makes for a much healthier outcome. Okay. So here's kind of an example of what happens when we don't have the biotic. This was just a test strip along the side of the road, regular seeding down on the toe of the slope, and that is not uncommon in many of the case studies and trials that we've run. I think an assessment of what success looks like is really important. I find that oftentimes we have revegetation efforts that fail, that don't go well, and we just sort of chalk it up to, oh, it must have been bad seed, must have been bad this or bad whatever. And I think that, maybe a second honest look at some of those problems, we just did not set the table properly. We did not provide Mother Nature what she was really going to need to succeed. And absent the necessary parts and pieces, it just takes Mother Nature a much longer time. So we've put significant effort into quantifying this over the years, and have the longest running case study of any biotic soil amendment manufactured on the planet going in a location called Milner Ridge. Now, the parent material is very sandy, so almost all mineral, very low organic matter, not a lot of living life going on with the microbial communities there. So wanted to do some installation, biotic soil amendment. Topsoil was going to be cost prohibitive given the location and the volume. And so an alternative was proposed. Now, the erosion control was determined to be a straw blanket. That was the best choice for this particular project. And everything grows in really nice, comes in just like we expect, and fills out rather nicely, choking out weeds, preventing any type of erosion that would require maintenance and callbacks. Now, this is a fairly critical embankment berm, and it's not just a slope. It's actually a berm that holds back a sewer lagoon. So this is really not where you want to have any kind of a failure situation or any erosion. Uh, and and this is the results that I think all project managers are looking for. And we've been monitoring this site for well over a decade now. And at the 8-year line, we wanted to go in and get some definitive analysis. So we pulled some plugs and sent them off to the laboratory and said, hey, we know the areas where we didn't apply biotic earth. We know the areas where we did, and we marked those out, staked them in the field so that we could get back to the same locations at future times and have that analysis done. And I was, quite frankly, when we got the reports back, a little stunned. In the areas where no biotic earth was applied, so you got your Milner Ridge B, we see our bacteria counts at about 1.6 million. Where we did apply biotic earth, we've got almost 18 million on the bacterial counts. And these are signs of healthy soil. They're alive. The microbes, the nutrients, the bacteria are working together. They're fixing nitrogen. The fungi is present. It's allowing those plants to access more nutrients and provide them what they need. And so when we see the differences, 4.8 million on our yeast versus 190,000, molds of 112 versus 15,000, I think that speaks significantly to the differences that aren't always seen with the naked eye. We don't see these. We got to go to microscopic laboratory analysis for these types of reports and information. But I think that's quite telling. So take you maybe a little bit more of a travel log here up to Girdwood. We're back in Alaska, about 45 minutes outside of Anchorage. Northernmost rainforest. So moisture's not a problem, but vegetation holding everything together is. And here our parent material is kind of shale and broken bedrock. We've also seen some very successful installations over shale on pipelines out on the East Coast. Pennsylvania area. So, here we are, revegetated on the same exact slope where we didn't have much going on, and now we've got lots of plants growing. Now the brush is starting to come back. This picture was taken 4 years after installation, so we're seeing more of our mosses, which we would expect in rainforest climate, but also starting to see our volunteer woody species coming back in. Now, I want to take you to Girdwood because this is the location of the Alyeska Ski Resort in Alaska, the steepest, longest runs. So come visit. Make a trip if you can. You will be well rewarded in the wintertime. Getting close to wrapping up here, and just wanted to show you one other alternate trial that's been occurring in different locations. Here we had the road maintenance crews come and regrade a shoulder using what they typically like to use, which is rock. And, rock by itself, we'd probably see some weeds and some more maintenance issues. So we just hand spread the biotic earth. Okay, you go through a little bit more material when you do this, but then we wanted to kind of see what we could do with rock, and that is the same patch. Now, if you contact your Verdial salesman, we visited this, I believe, a year ago, perhaps longer. My days are really running together with all of the shutdowns now. But this has been well vegetated, and we're actually building soil in these places now. And I kind of get to a point where I don't know what else to say. We've just seen the successes so often that it's become the new expected normal. Uh, this is just a shot of what it kind of looks like going down. So we get quite a bit in a truck, cover quite a bit more area. And the reason I'm showing this particular location is that the soil that they are applying onto there is at a hydroelectric dam project. And what you wind up with on the top when you do projects like that is the soil that came out of the bottom of the hole, the foundation for the dam. So it's very mineral, no organic matter. There's just nothing to it. And this is pretty far north in Manitoba, and this is just one growing season. So when we extend and improve the outcomes, when we get the benefits of a longer growing season, when we increase germination, water holding capacity, bring the necessary beneficial bacteria and microbes back to the soils that Mother Nature needs at a fraction of the cost of our traditional methods, we think we've got a recipe for success here. And we're seeing that in more and more locations around the world. So I will close with this last slide, and we'll check our question box. I haven't seen any come in. Again, my name is Alex Zimmerman. I'm with ECB Verdial, manufacturers of Verdial Biotic Earth. If there is any information that we can provide to help you on your next project or any design considerations, we're happy to do that. Just reply and reach out to you when you get your CE certificates in the email there that you signed up with, and look forward to our Tuesday, Thursday continuing education series. We got a pretty good schedule, I believe, all the way through May mapped out to provide an opportunity where we can pick up a little bit of education, a bit of training, maybe further our understanding of some of these materials and methods to benefit us on our next construction project. And with that, seeing no questions, I think I went a little bit faster than I had expected. But I will go ahead and sign off now. Thank you all for attending, and be safe. Take care of yourselves and your families, and look forward to getting out there and opening things back up just as safely and as quickly as we can. Goodbye.